Okay, before we move on, let's just take a look at the zero force members when a member is considered zero force member. Okay, so I'm not going to go into extensive detail of this. I'm just going to share a few points so that for our next example we can be ready. Okay, so here the first point is at a joint, if there are two members and no support and no applied force, then both of those members are zero force members. For example, right over here, this is a joint. You can see that this is a joint and there is no support or any forces on this joint. Thus, these two members are going to be zero force members. So this is a zero force member. This is also a zero force member. Similarly here, this is another joint right over here. So two members. So this is a zero force member. This is a zero force member. And the same case happens here. This is a zero force member. This is a zero force member. Now the thing is, if there were a support or any applied load at the joint, then these members would not have been zero force members. For example, if I say that there is a support here, say there you go, there is a support, or there is a force acting in this direction. There you go. In that case, we cannot say that these are zero force members, but here for this example, we can say that this is zero. These forces are zero force members. Another thing to notice is that for this rule, if the angle between the two members is equals to 180 degrees, then this rule shall not apply. It must not be equals to 180 degrees. This is what that's been written here. Okay, all right, so let me just erase all that and then we move on. Okay, so let's move on to the next rule. This rule says at a joint two members are parallel. So you can see that this two members, this is a member, this right over here is a member, and here's a joint, and this right over here is another member. So if two members are parallel, then the adjoining member is going to be a zero force member. So this member is a zero force member. Similarly, right over here, this is a zero force member, and this right here is also a zero force member. Okay, let me just erase these and we're gonna move on. Okay, so let's take a look at another point, that is that if a member has hinges at both of its ends, then that particular member is also a zero force member. So this right here is a zero force member. Okay, now that we have covered all of this, another thing I should mention to you is that if there's a situation like this is a joint, let's say this is a joint, one member goes from here, another member goes from here, and the angle between them, this angle is of 180 degrees, and let's just call these members, let's call them AC and BC. Okay, so in case AC member turns out to be a zero force member, we don't know yet, but once we are doing our calculations, we see that AC member is a zero force member. Then subsequently, we can easily tell that BC member is also a zero force member. So what happens here is that in this case, if AC was not a zero force member, and let's say AC had a force that was coming from this direction towards the joint, then BC would have to have a counter force to keep it in the equilibrium. That is why in that case, if AC is not a zero force member, BC cannot be a zero force member. Similarly, if AC had a force that was going in this direction from the joint, then BC must have a force in this direction to keep the joint in equilibrium. But since AC is a zero force member, there are no forces here, that means BC does not have to have any forces to keep the joint in equilibrium, thus BC can also be a zero force member. So that is the logic behind it. Okay. Alright, so that's about it, about the short notes on zero force member. These are not in-depth explanations or practices. So if you do have lackings in the zero force members field, or if you do not know how to find out zero force members, I'd suggest that you should practice on that. Okay, so that is it for this video. I'll be seeing you in the next one. Thank you very much for watching.